Kubernetes and EKS. Here is a diagram depicting what we are going to build. Before we jump in, make sure that you have these following tools set up on your local development environment. Make sure you have AWS CLI. Make sure you have Minikube. Make sure you have kubectl. And then finally, make sure that you have Docker installed. In this video, we are going to be using the AWS CLI for getting things done. There are more next level tools than the CLI for getting cloud development done. For example, the AWS CDK or Terraform, but I like using the AWS CLI, at least for starters, to get a good feel of how everything works and is set up. Here is a repository that I have referenced in the description for this video, where you will find all of the configuration JSON and YAML files that we will be using, along with a READMEs directory that has a enumerated list of markdown files, along with this root level README file that has all of the reference material that I use to learn what I'm going to show you. Okay, so let's jump in, starting with the first markdown file, right? So you can just follow along, 1, 2, 3, 4, 5, right? Each markdown file, you can just read from top to bottom with the sequence of commands that we will be issuing. In 1.md, you will find first me checking the versions of the development tools that I am using. I've shown you this already. Now let's get to the next step, which is creating the Cluster VPC. I will be creating the Cluster VPC via a YAML file and a CloudFormation command. This is the CloudFormation command. This, for your reference, is where I originally got the VPC YAML file from. But here, let me copy this CloudFormation command, issue it. Right, let me time, and right, so let's see how long it takes to create a VPC. So it took about 1 minute and 11 seconds to create a VPC. And now let's get to the next step, 2.md. In this step, we are going to begin creating the worker or slave side of the Kubernetes cluster. In a Kubernetes cluster, you have the control plane or the master side of the cluster, and then you have the worker or slave side of the cluster. When we use EKS later in this video, we will use EKS to provision all of these control plane components. Right now, we are working on the worker or slave side of the Kubernetes cluster. Let's start by associating the VPC that we created with the worker nodes that we intend to be in this Kubernetes cluster. So we do this like so. First, we'll need some IAM magic to happen. So we create this role. You can verify that the role was created by searching for the name that you chose for the role. Now let's attach this managed policy to the role that we just created. Now let's create the worker nodes, or let's start to create the worker nodes first by telling EKS all of the subnets that we created in our VPC, and we do that with this command. You'll need to replace this section of this command with the subnet IDs for the VPC that you created, as well as the security group ID for the VPC that you just created. You can find those subnet IDs and security group ID or IDs with this command. This will spit out all of the stack resources for the VPC that we just created. You run this command, and then this stack.json file will be updated with all of the resource IDs and information for the VPC. You can find the security group ID here, right? And you can scroll through to find the subnet IDs, right? So this one, subnet ID 1, 2, and 3, right? So you would use those IDs and eventually you'll get this command to look something like this. And we will time this as well. Start the timer. And we'll come over to EKS. All right, creating. We'll refresh this. So it took 9 minutes and 22 seconds roughly. This is where kubectl or kubectl or kubectl comes in. This will configure your local kubectl or kubectl tool to point to those worker nodes or the EKS cluster that you just span up. And now we can move on to step 3 or 3.md. For 3.md, we continue developing the worker or slave side of the Kubernetes cluster. In this part, we will define what instance types the workers will get provisioned with. And before we do that, we need to do some IAM magic, starting with this command right here. Oops. I have to copy it. Then we need to attach some managed policies to the role we just created. 1, 2, and 3. And after we have the role set up, we will use this command to continue setting up the workers. Make sure that you replace the subnets section with the actual subnet ID of your VPC. Copy. Okay, so that took an additional 2 minutes and 45 seconds. We added the configuration that defines what instance types each worker will get provisioned as I understand it. Okay, so that means that now we're done configuring the worker side of the cluster. Now we can use the kubectl or kubectl or kubectl tool to create some Kubernetes primitives to allow the control plane to schedule our app pods onto the worker nodes now. So let's do that in 4.md. Here is a chart showing the most common Kubernetes primitives. There are more than these, but these are by far the most common. These are like the building blocks or Legos that you build your Kubernetes apps on top of or out of. Deployments are used for scheduling your containers and pods onto your worker nodes. Persistent volumes primitives are for establishing data sources that need to persist beyond the life cycle of a container. Ingress is for connecting your services and pods that run inside of your Kubernetes clusters to the outside world. A pod is a wrapper around your containers, usually Docker containers. A persistent volume claim is used by your services and pods to connect to persistent volumes that have been defined. Services allow you to scale your pods and deployments and replica sets, manage the desired state that your deployment should be in. Storage class, never use that. Config map is for defining shared configuration across your microservices. Namespace is a tool for organizing your resources in Kubernetes. Stateful sets are for being able to scale usually databases in a logical way that actually works. Volumes are for mounting data into your containers, but are not supposed to be used for long running or changing data like a database. It's more like for mounting static files. Secrets are like config maps, but for sensitive data. So anyways, you can build your applications out of these primitives. So let's use some of these primitives to deploy a Node.js Express API into the Kubernetes cluster. So for MD starts with these commands. Create a namespace. Config map. All right, these are all primitives from that chart we just saw. And you can use this to check that you have resources in the cluster. So you see we have a status of container creating. The container is being stored in ECR, Elastic Container Registry. That is the AWS hosted container registry service. You define your image here. So should be up by now. Right? So the container is running. So now we want to expose our container to the outside world. And we do that with a service. So eventually that should give us a domain and DNS name that we can access the service on. Let me format this. There you go. So this is the IP address of the load balancer that was created by the service. If you come in here, you'll see a load balancer was created. This creates a classic load balancer that will forward traffic to the target port of the containers that are specified or selected by this tag. So we should be able to access this after a few minutes and hit our container or our API, and then we are done. So this API server has an endpoint called DevOps. It says hello world, look at that. So if I come here and I delete the service, eventually our traffic should go away. close this, reload. All right, so no longer accessible. That is a crash course on Kubernetes and EKS. Make sure that you go ahead and follow 5.md, where you will find all of the delete commands for deleting all the resources that were created so you don't get charged and don't rack up a bill. I think if you just let this thing sit, it might cost you about $60 to $70 a month, if I'm not mistaken, maybe more, maybe less.